Tyranny of OIDs by Justin Ryburn. So everybody give it up for Justin. Do you want this guy? Yeah, just turn it on.
All right, can everybody hear me? There we go. All right, thanks, Anna. As mentioned, I'm Justin Ryburn. My title is Consulting Engineer with Juniper Networks. That's just a fancy way of saying I'm an SE, essentially. What I'm going to be talking to you guys about today is SNMP must die, the tyranny of OIDs. Essentially a comparison between the current telemetry model that we use today with SNMP, and I do have a little visual aid here. Shirt says death to SNMP. So the goal here, in my opinion, is to come up with a better method of getting telemetry data out of our network infrastructure than doing SNMP OID gets like we do today. All right, so start off, question, anybody in the audience know off the top of their head what this is? Nobody? All right. Yes, it is an SNMP MIB, or OID. Specifically, that one there happens to be the operational status of interface from the IF MIB. Thankfully, nobody got that right, because if you had known that, I think you probably need to seek some mental health professionals, because nobody should have things like that memorized in their head, right? How about this one? Anybody take a guess at, even if you're not familiar with streaming telemetry and the Yang model for interfaces from the IETF, anybody want to take a guess what that is? All right, same information. It's the operational status for an interface using streaming telemetry model to get at that data. So what makes, other than just obviously the ease of seeing what it is that you're requesting and potentially being able to actually memorize them, what is it that makes streaming telemetry better than SNMP? I think the first thing that always comes up when you hear people talk about streaming telemetry and its value over SNMP is that it's a push model versus a pull model. So instead of having your monitoring station going and doing SNMP gets of OIDs and getting values back, you're actually configuring your network infrastructure through one of a couple of methods to push the data to your management station. So it collects the data on box and pushes it out in a streaming fashion, hence the name streaming telemetry, to your management station. I think these are in no particular order as far as importance, in my opinion, just things that I thought of as I put them on the slide. But the next thing that I think of is that not all information is stored in SNMP. I'm sure all of you as operators have run across the problem where it's like, gee, I'd like to get this particular value out of my box that I can get in the CLI, but my vendor hasn't implemented that as an SNMP MIB, so what do? I have to go screen scrape or something along those lines to get that data, and I'm not a very good programmer, but I always struggle with trying to do that. And that kind of leads me into my next point. Another advantage that streaming telemetry has is it's based on model definitions that give us a much more structured way of getting the data. So it's much easier to ingest into whatever systems we're writing if you have DevOps folks or if you're a DevOps person yourself. Much easier to get that data, understand what it is, to write code and logic around that data. You know what type of value you're going to get back. You know whether you're going to get an integer or you're going to get a string. So it's very much more easy to approach. It's also very extendable, similar to, I guess in this case, it's similar to SNMP, where you can have standards models that are defined industry-wide. You can have them defined by the IETF. You can have them defined by the Open Config community if you're familiar with some of their Yang model work. And the vendors can also have specific models for things that might be specific to their implementation. There are a couple different transport options that we can use for this. We could use UDP, where we just fire it out of the device and forget and hope that it gets to where it's going on the management station, which might have some scaling benefits to it, but obviously has the downside of not knowing whether the data got there or not, and not having encryption on the mechanism. Then we also have a TCP-based version that is being worked on, and I think the vendors are starting to implement, that allows you, of course, authenticate your TCP session, sequence number, error check, all the things that you expect of a TCP-based session for transporting this data, which you obviously can't do today with SNMP. And the argument is that it's scalable. And so the question is, is it really scalable? And this happens to be, since I happen to work for Juniper, I have easier access to that data. This happens to be on a Juniper device, on a routing engine. This particular one is gathering 60 different metrics, total of 500 objects every 15 seconds, and this is the graph of the CPU utilization of the routing engine on the device as it's gathering all of this data. You can see the numbers here, but that includes 176 10 gig interfaces, errors, inputs, outputs, Q stats, a lot of data. If you were to go and get this data with SNMP, needless to say, if any of you have ever tried to get this type of granular data, you're going to spike the CPU, especially if you happen to be doing route convergence at the same time. Open or closed solution. So this is similar to SNMP. This is an open solution. There are multiple vendors that are working on supporting their own implementation for this. Off the top of my head, these are the 3 that I'm aware of that have code that's shipping that have at least some pieces of a streaming telemetry solution in them. There's still a lot of work going on in the industry to work on the standards around this. So a lot of the formatting of the data is either in JSON, netconf. Google's come out with one called protobuf. If you haven't taken a look at that, it's a pretty interesting data and export format. Like I said, we can do either UDP or TCP transport of the data. And there's actually some work going on to define a subscribe method in the gRPC definitions, proto definitions that the open config community is working on, so that you could do gRPC calls for your configuration, but you could also get your op state out of the device and get your streaming telemetry subscriptions done all through the same TCP gRPC channel. And like most things in networking, that's not where the story ends. There's still, like I said, a lot of things going on, a lot of work still being done around this in the IETF and the open config community and in the vendor community as well. Last slide, just to wrap up. A couple blogs here, both from us and from Cisco, that kind of go through a little more detail of what streaming telemetry is. If you're interested and want to kick the tires and play with it, please contact your vendor, contact the reseller that you use to get your networking equipment, and ask to see a demo or ask where they're at with their implementation of this. And the main reason I wanted to come up and talk about this today, other than trying to be an evangelist for this, because I think the technology is cool, is I'm considering doing a little deeper dive on how this all works at a future NANOG. So if you have interest in that, my email address is here. Please let me know. I'm kind of trying to figure out what the level of interest might be in that. That's all I had. I don't know, are we doing questions now, or you want to do questions at the end? All right. Thanks, everybody.
All right. Yeah, and since we're very limited for time on these lightning talks, if anybody out there has questions, please feel free to find these guys during the beer and gear at 6 p.m. And next up, we have using IETF's L2 NSF to mitigate DDoS attacks, presented by Linda Dunbar.
Thank you for the introduction. Okay, good afternoon. So today I'm just using a few minutes here to give you an update of a newly chartered working group in IETF, interface to network security functions, and show how to use that to mitigate DDoS attacks. And the co-chair for that working group is Adrian Farrell, representing Juniper, and myself, Linda Dunbar, representing Huawei. And we have one vendor implementation prepared by Rakesh from Juniper. Okay, so more and more today, we see overlay network, right? Be it CDN network, overlay over existing infrastructure, or could be IoT, could be video conference network. So lots of overlay networks over the top of the shared infrastructure, which include routers, switches, links, network functions, virtual and physical. So the security for the virtual network, there are many aspects for the security, right? So there could be AAA, authentication, authorization, and lots of that work has been done at the overlay layer. So they have their own AAA engine to do the authentication. But for other aspects, though there are parts can be done by the overlay, but underlay can provide lots of features, lots of capabilities to reduce the pain overlay network can feel. especially if your overlay network is under attack. Like your access ports, your access link can be saturated with DDoS attack traffic, make the overlay nodes could not be able to receive the traffic they need to receive, or could be delivering from between overlay nodes. Those other things can be supported by the underlay. The IETF I2NSF is to provide these hooks to allow the underlay network to provide this interface to allow the overlay be able to dictate how traffic should be delivered, when to deliver it, and how to deliver. So the overlay network lost more and more often. You can see the endpoint being mobile, right? This BYOD, bring your own device to campus, allow different kind of devices to be used. And so security is a big issue. So with overlay network themselves imposing security rules, imposing security functions, they have their limitation. Even though you could have encrypted traffic between your overlay nodes, you still cannot prevent DDoS attack. And also that any kind of predefined header, like you use header as a criteria to set up rules, those kind of header can be compromised. For example, you may have a video conference network, and you only allow A talk to B with this kind of port number. But with a static setup, you have to allow a range of ports to be able to communicate among those nodes in the overlay network. And but any kind of sophisticated users can hack to those information and be able to attack those overlay nodes. So the I2NSF approach is to allow the overlay network be able to dynamically set up the ports. For example, we are using WebEx conference call. And when you request the call to the WebEx controller, I'm just using WebEx as an example, the conference call controller can set up the UDP port for this communication between A and B. At the same time, this controller can send a dynamic rule to the underlay network saying A and B with this UDP number equal to 1598 can talk. Once this talk is finished, then that rule is removed. So with that, you can guarantee when a particular node is under mission critical missions doing some work, no other traffic can saturate the link. So this is to allow the applications or application controller to dynamically set up the rules for their communication. Okay, many of the companies here have been doing like automation, right? But the key of automation is to be able to have the standard interface. With virtualization, like now we have lots of virtualized network functions, virtualized security functions in the network. It is possible for the provider, service provider, to provide security solutions based on the client need. The client can specify what kind of rules they need to have, and then the provider be able to find the service functions or virtual service functions and instantiate them at the right location to achieve the optimal protection. But the problem is different vendors, even though they may have same function, all those functions, simple functions like a firewall, could be one vendor and another vendor, they all have different interfaces, right? So making this automation very difficult to achieve, or making it very troublesome whenever you have a new vendor introduced and then you have to change your interface. So I2NSF's goal is to be able to provide those standardized interface and for those dynamic rules. And for vendors, if they do already have their own implementation, they can put a shim layer to translate this IETF standard interface to their own command line. So that's one of the goals for I2NSF, is to be able to have those kind of standard interface. So for the service provider, security service provider, to be able to use the standard interface for their controller to control, instantiate different security functions and use them for their client. Okay, so here is the framework of I2NSF. I2NSF, we have two types of interfaces, actually three types. The two types of interface shown here. One is the client-facing interface. That interface is for giving like intent-based policy. We don't want to make like a over the sky, like a very abstract intent, but being able to have the policies based on client addresses, client IDs, and then the controller can be able to translate those kind of client-oriented rules to the rules which can be understood by the security functions. So the next interface we call NSF-facing interface. The rules over the NSF-facing interface will be represented by the rules most vendors' devices can comprehend. And there's another interface I didn't show here, is the vendor registration. When we did this multi-vendor service chain project for the Etsy NFV, one thing we realized that different vendors have different, same function, they have different capabilities. And when you have a catalog of virtual network functions, when you want to utilize them, and you realize that same name can have different capabilities, but different name may have same capabilities. So in order to make this automation all work, you need a registration interface. Allow vendors to register the functions, type, and their capabilities with this controller. So here is the update of I2NSF. The charter is listed here, and there's a mailing list. So for companies, vendors, and providers who are interested in this, please subscribe to the mailing list. And we already have 4 working groups drafts, and one of them is ready for last call. So looking forward to more input from the community. Here just showing one vendor implementation. And there's a YouTube video showing the demo of how they do the SD, software-defined secure network, how they achieve that. And here are some of the commands they show on the YouTube. Due to time, we don't have time to do the demo here. But I highly encourage you to watch the YouTube and to see the vendor implementation. With that, that's it. And any questions, you're welcome to talk to me at the social tonight. Thank you.
All right. Thank you very much, Linda. Next up, we have Mike Kirshnoff, and he's going to tell you about verifying your network topology using packet injection.
Cool. Actually, it's my first NANOG, so I'm a little bit nervous, but it should be fine. So, my topic is about how to identify network connection using networkware. Sometimes improperly connected cable leads us to faults which hard to troubleshoot or hard to identify first. And we want to solve this problem with software approach. So how we are doing? At first, you need some kind of topology representation, and different solutions are available. Most popular topology representation format would be YAML and JSON. So you just specify your node, and everything is needed. Every link will have a name, and we implement this solution for Vagrant, for example, but it could be for any orchestration method. So you have topology, and orchestrator will spin up this topology for you, and after, Ansible hosts would be created for future management. So let's talk about solution itself. What is our packet injection and how we approach to solve this problem? We don't care about any routing protocols, and what we need only Linux-based system, which is implemented on most vendors, and we use raw sockets to inject packet. It's important that port should be opened. If port is shut down in shutdown state, so we cannot verify that to send packet. Okay, what we need to send packet? At first, we should specify sender port which we want to use. It will be some Ethernet port for Linux, for example, and we will need destination MAC address. Python script, which is part of solution, will connect to every available device through SSH, and will retrieve destination MAC. So now we have all topology, all devices with all available MAC addresses. As second step, script will will connect to each device, and each device will be considered as sender for packet and as a receiver. So every device will be presented in two rows. Let's look at workflow. Everything is open source. You can go to this link and download the files. After you did it, you need to set up your environment. It's pretty simple and already predefined. You just use Vagrant app for spinning up the boxes. And after you need to apply playbooks just for some passwordless authorization based on keys and copying some files. Let's look how we do it in a manual way. And in manual way, we just trigger script send row, provide used port to which we want to send packet. When we create just two IP addresses, it could be any IP addresses, and we really don't care because, as I mentioned previously, it's not a routing-based solution. It's pure packet injection, and we don't care about IP addresses. And we need destination MAC address to reach our neighbor. So when the packet is sent, we should run on receiver node, usual TCP dump, and most systems support TCP dump. And we will receive our packet with current provided IP address, and that's how we verify that link established between these two devices. As I mentioned previously, if port is down, we cannot do it. And all we need is basic Linux-based system plus TCP dump. Now we will take a look at Python workflow. Script is already written, and you can simply use it. It will go to each nodes available in our topology. YAML file is used by default, and you'll find topo.yaml file in GitHub repo. And result of this script will be a list of all available devices and device with connections problem in between. So something is wrong, and you want to verify that, for example, server 2 and tor 2 is connected properly. Also, for Vagrant implementation, it will show you what's wrong and which links you want to enhance or not to enhance or to correct, because maybe link in Vagrant open just one side. And as I mentioned, everything is on GitHub. Check out our new site, XRDocs, latest work shared there, and follow us on Twitter. And this tool is part of bigger open source test framework, and my colleague will present it tomorrow at 5 p.m. So thank you for attention.
All right, thank you, Mike. Next up, we have Yaoqing Liu, who's going to present on college immersion in educator's view.
Hello, everyone. Yeah, my name is. Oh, sorry. Yeah, my name is Yaoqing Liu from Clarkson, and actually this is my 6th at NANOG. I think it's 2010. When I was a student, I attended NANOG, and I benefit a lot, and that's why every year I regularly attended at least one NANOG. And since last year, actually we have this college immersion program. So we already have 9 students supported by NANOG this program, and to come over here. Actually, we have some students here you may already talked with. So yeah, this is a great community and with great people like you here. But when I talk with the people, the first question they come up with me is that, where are you from? Yeah, actually we are Clarkson University is in upstate New York at the border US and Canada, and we are a small private university, but it's research oriented. So we are at a computer science department, and we have some labs. So we have Clarkson Open Source Institute labs, internet teaching labs, and virtual reality lab. And all these labs, actually a good feature is that all our students administrate. And they maintain all these networks, servers, software, and hardware. And even we have official mirror site for Linux distros. Actually, every day we have about 1 terabytes traffic, for mirroring traffic, for user downloading those mirrors. And also we host GNU software and Linux kernel. Our students basically work on a variety of projects about systems, about networking. And this is the picture for our student maintained server room. And we have, you can see we have some switches there. And actually those switches are mainly supporting the infrastructure and the service. And actually we don't have much flexibility for network operation, testing or experiments, right? So actually that's come to our next topic. Current, we wish we could build a dedicated and open networking lab. So in this lab, we hope we have a diverse network devices and the routers. Actually, we really don't have a router at our lab because we are a small university. There's only one edge router on campus. And using those resources, we can our students can have hands-on network operations, and they may have various training research opportunities over topics like routing, security, measurement protocol, and so on. So actually, as you can see, actually our goal really matches well against our NANOG mission to get more blood workforce into this community. And also we are very positive to be involved in this community, as evidenced by me regularly attending this conference, and also we have so many actually students request when I spread this news to our students. We are really positive to be get involved more in this community. However, definitely we have limited resource. Unless somehow you could help us a little bit, that's the topic. What can you do at NANOG to help us a little bit? So I think the first thing probably, or the easiest thing, just to share, tell your network operation stories, and share your experience, no matter good, bad, even ugly. Tell us, and hopefully our students can take that for lessons for their future career. And another thing probably you can do is to introduce job intern opportunities over the summer to our students. Also, in addition, you could sign up or present in our career fairs. Actually, at Clarkson, every year we have 3 career fairs. So a lot of employers, they just set up a booth, during these career fairs and recruit students. And meanwhile, you could provide us real-world project ideas, okay? And the important thing is you could follow up or even probably supervise our students, okay? So actually, if you want to do more, sure, we have more ideas there, more thoughts about that. So basically, you could share your data. So those data probably, when you deliver those data to your customer, probably for you, the commission is accomplished, right? But for us, the efforts just get started. We really want to use this data to research their traffic patterns, to research user behaviors, and also study those security issues. Okay. So offer your traffic trace and routing information. If those data are a little bit sensitive, we can sign NDA. Also, you can do some anonymization, and before sending us, right? Different forms, and actually the potential outcomes are significant. So basically, we can have insightful discoveries over this data, and actually that could end up with a master thesis, PhD dissertations with high quality publications. Okay. And if you want to contribute more, actually, another thing is actually you can donate some equipment for us. Okay, for you probably those just maybe some junks you want to throw away. Probably you have to pay money to throw them away, right? And for us, those are treasures. So, our students we want to play with them and want to take them into apart and assemble them back to work. Okay, so basically offer your used routers, switches, servers, even modular small data center devices, UPS, those things, and furthermore you can offer your new product for us to try out to test. So also the same thing, significant potential outcomes. So we have our students engagement, and also they have we could train them with hands-on skills, and actually even you could offer certificates based on the training and the student involvement. Okay, if you want to contribute more, actually offer some financial support to our students, and for you probably just a little bit small amount of money, but for us really a great favor to support our students and our research. So probably you can find, for example, a course, start with a course. For example, a course name could be network operations, or you can fund the lab sessions to pay faculty's efforts, and also you could establish scholarships and some research grant to basically get students involved. So yeah, considerable outcomes. So we could end up with cutting edge technology and with new workforces to the whole NANOG community, right? So yeah, final words. So I'm sorry if I have asked too much from you guys, but by no means this is a criticism to our NANOG, but we got a lot of appreciation to the college immersion program and then the whole NANOG community, and we really benefit a lot, for the students. Hopefully, this could be a cornerstone thoughts to initiate a more productive discussion about the college immersion. What is a college immersion? What does it mean? All right. So I think that's all. If you want to start with a pilot program from our university, we will be more than happy to talk with you. shoot me an email. My email is liu@clarkson.edu. Thank you very much for your attention.
All right, those are some really great lightning talks. So thank you very much, Justin, Susan, Mike, Yao Ching. Thank you very much, everybody. Give them another big hand.